Rightio, here we're going to have a go at finding the area bounded by a couple of curves, which I've sketched over here. And the key thing is bounded by the curve, so this point and this point are key. This one's obviously the point 0, 0, everything 0 works. To find out this point, let's just equate the two curves. So we end up with y squared equals 2y minus y squared. Bring it over here, we get, obviously y equals 0 is a solution, but there should be another solution as well. So 2y squared equals 2y, or y squared equals y. And that means that y has to equal 1. Okay, so this is the point where y equals 1, and if y equals 1, x also equals 1. So that gives us our points. So the points we're interested in are 0, 0 and 1, 1. Okay, now given that we've got this in terms of x equals, it's going to be easier to do the y integration first. So we're going to end up with the integral from 0 to 1, and then the integral from, we know we're going to have y squared and 2y minus y squared. The surface that we're overlaying has just got a height of 1, and then this is going to be dx dy. Okay, so we're doing our x's first, and we know that x equals, so these are x limits. Okay, so these are the x limits between y squared and 2y minus y squared. And once we've got that sorted out, then we're going to do the y limits between 0 and 1. Okay, so the integration here doesn't look too ugly, so we're going to have 0 to 1. If we integrate this thing dx, we're just going to get x between y squared and 2y minus dy. Substitute these things into the integral. 0 to 1, first one 2y minus y squared minus another y squared dy, which is integral from 0 to 1, 2y minus 2y squared dy. Carrying along, we get the integral, do the integration, we end up with y squared minus 2/3 y cubed between 0 and 1, which is the zeros are all obvious. So that's going to be 1 minus 2/3 is 1/3. Okay, so the area of this area here is 1/3, which sounds about right, given that's a square of 1 by 1, so that's 1. This seems to occupy about 1/3 of it. Looks reasonable.